Alright, this is 8.5b in trig, and we're going to continue on, and we're going to start with the first example. And it's asking you to plot points with polar coordinates. Okay, so what we're going to do here is plot those, and then it says determine the rectangular coordinates of each point. So we're going to start by just plotting the polar, and then we're going to go from polar to rectangular. So I've got this handy dandy cool little polar graph here, and the first one says point P is at 30 degrees. Alright, so point P is up to 30 degrees and then 2 long, so I can just determine any way I want. I just label that 2, it doesn't matter. That's just where I'm going to put 2. Actually, if I were to draw this correctly, I would say that my R is 30 degrees and that 2 is actually right to there. Because, nope, I guess it's not, is it? It would be there. That would be 2. And I was up 30. So let's make my little polar thing bigger, because I can do that. And that would make it easier then. Alright, so let's look at Q. Q is -4 2 pi over 3. Okay, so I know that 2 pi over 3 is 120 degree angle, and it's 4, or -4. So let's look and see what that negative means. Let me go with a bigger pencil here. Alright, so first thing I'm going to do is look at that, and it's 120 degrees. So I'm going to get 120 degrees. So here is my 0. 120 degrees is right there. So there's my 120 degrees. This part here says that the length of R is 4. So length of R is 1, 2, 3, 4. But this negative here says that it's 4 in the opposite direction. So let's do that in green. So following, going 180 degrees, I've got 1, 2, 3, 4. So the length of it is 4, but since it's the opposite direction, then that is the line that I'm looking for. So the key here, when they give you this, is go to the angle, and if the R value is negative, once you get to the angle and you draw the R, then go the opposite direction along that straight line. Okay, so let's get rid of this and look at another one, because these can be a little bit tricky. Alright, let's look at the C portion. C is R, 5 -pi over 4. Alright, so again, we're going to go our angle. Pi over 4 is a 45 degree angle, but it says negative. So we're going to start here at 0, and we're going to go negative 10, 20, 30, 45, somewhere around down here, I think. Okay, so that is my negative pi over 4, or my 45 degree angle. It says that my R value is 5. So 1, 2, 3, 4, 5. There is my point in the fourth quadrant, and it's 5 long. Okay. Now if this were a -5, then I would graph it just like I did, but then I would go in the opposite direction 5. So this would be my -5 length, the opposite of the green one. Okay, so that's what the negative shows, is it's just going to, wherever it ends up, as if it's positive, you're going to go the opposite direction. So again, do the angle first, then do the R, and then go the opposite direction if that R happens to be negative. And the second part of this example said determine the rectangular coordinates. So I'm going to take my P and that was 230 degrees. What I'm going to do is I'm going to change that to rectangular coordinates, so an x and a y instead. So my rectangular coordinates are x, y, my polar are r, theta, and that's what I have right here is polar. So let's change it to rectangular. Alright, so let's use this chart here from page 359 in order to switch those around. Alright, let's see what I've got. I'm looking for x, and that equals r cosine of theta. X equals 2, that's my r, cosine of 30 degrees. And because you're so stinking smart, you know that your x equals 2, and then you take your calculator and find the cosine of 30 degrees, which is adjacent over hypotenuse, which is going to be square root of 3 over 2. And there's just a reminder, 30-degree angle, it's going to be adjacent over hypotenuse. Okay, so that's my x value. Those cancel. So my x is the square root of 3. My y then is right here, r sine of theta, or 2 sine of 30 degrees, or 2 sine of 30 is going to be opposite over hypotenuse. So that's just going to be 1/2, which equals 1. So my x value is square root of 3 from here. My y value is 1. Alright, so those are my rectangular coordinates. Square root of 3, 1. So basically what that's saying is this point up 30 degrees too long is going to give me the point square root of 3, 1. Okay, so I can do this on the rectangular coordinate system, this on the polar, which is what I have here, and I'm going to end up at the same place. I just am changing between the two. So let's do the B portion and the C, just so you have some practice. Okay, there's B. X equals r cosine 2 pi over 3, and y equals negative 4 sine 2 pi over 3. Alright, we've already determined that 2 pi over 3 is a 60 times 220 degree angle, okay, or a 60 degree angle in the second quadrant. So x then is going to be negative 4. Cosine in the second quadrant is going to be negative, and the cosine of a 60 degree angle is 1/2. So that's going to give me a positive 2. My y is going to give me a negative 4, and sine is positive in the second quadrant, and it's the square root of 3 over 2, which is going to give me negative 2 square root of 3. So my rectangular system is going to look like that. So this is the conversion from the polar system right there. Okay, this letter C. R is 5 negative pi over 4. Alright, this one really isn't too tricky. We'll just put our x equals r cosine negative pi over 4. Okay, and negative pi over 4 is, let's draw a coordinate system here and draw where it is. It's a 45 degree angle over here in the fourth quadrant. Since it's negative, we went this way. This is 1 square root of 2. So the cosine of negative 45 is going to be adjacent 1 over hypotenuse, square root of 2. Can't have a radical in the denominator, so we take square root of 2 over square root of 2, and we get 5 square root of 2 over 2 for our x value. Now let's look at our y value. Y equals r sine of theta r is 5 sine of negative pi over 4, which again is this angle over here. But sine is opposite over hypotenuse, which is 1 over square root of 2, and then I do that with my radical and get that. Okay, common mistake here is to think you're done there. But one of the things that's important is sine in the fourth quadrant is negative because it's opposite. Opposite over hypotenuse. Opposite here is a negative 1. We went down negative 1, so that means this is going to be a negative. Whereas when we are doing cosine up here, all students take calculus. It's positive here because it's adjacent, positive 1 over the hypotenuse square root of 2. Okay, so those are my coordinates. 5 square root of 2 over 2, that's my x, and my y is negative 5 square root of 2 over 2. And there's my y. So this is the same as that. Alright, so that's it for 8.5b. I still have, maybe 2 or 3 more videos to go. So anyway, hold on guys.